His father
Feel
told
that?
him three
This
things
soil
when he
holds
was 20 years
stories.
old.
It's so rich
5
and
years
deep.
to begin.
Now press down
20
deep.
years to
The
trust.
rule of 50 years.
50 years to
What you
know.
plant today feeds the
Elias
future.
Mast spent
Feel it.
51 years pressing his hands into the same
Hold on.
Lancaster County
That map
fields.
can't be right.
When a precision agriculture
assure you
company
the
tried to
data's
sell him a
accurate.
soil mapping
Your
service
data
for
is wrong. I know this
$15,000,
land.
the most
Let's
advanced
discuss
system
this after.
available, he
This
asked
core
one
matches
question the
10
salesman
with
couldn't
moisture.
answer.
Feels
The
rich. Let's
company's
see how it
founder
smells.
drove from
The
Philadelphia
chart
to find
confirms
out
it's
why.
fertile.
He left
Earthy
with a
and fresh,
revised
that's the sign.
understanding of what his
Agreed.
company was
Healthy
actually
soil.
selling. And
Let's
with the
see, 40
specific
years of
discomfort of a
tending the
man who has
soil.
built
What's that
something
worth?
genuinely useful and
He
has
put
just
his heart
learned what
into
it
every
cannot do.
acre. That's the real
What
deal.
Elias's hands know.
A life's
What the
work
sensors
valued
can't
right
reach.
here.
And what happens when
Press your
both of
hand
them
in
are
deep.
right.
Feel the warmth.
There is a kind of knowledge that
crumbly, but
cannot
I
be
feel it.
transmitted by description.
That's the warmth
You
of
can describe
biology.
the color of healthy
Life in the
soil,
soil.
the dark brown that
I feel it
approaches
now,
black in the
Grandpa.
highest organic matter profiles, the color of good coffee or dark chocolate, or the specific shade that soil scientists call tenure 2-1 in the Munsell color system. You can describe the texture, the way well-structured soil crumbles when pressed between the fingers, releasing from the compression without smearing, holding its shape briefly before fragmenting into the small aggregates that indicate adequate organic matter and biological activity. You can describe the smell, the particular earthiness that comes from geosmin, the compound produced by Streptomyces bacteria and released when healthy soil is disturbed, the smell that people call petrichor when it rises after rain, and that is, technically, the smell of life. You can describe all of these things accurately and completely, and the description will tell the listener almost nothing useful about how to recognize them in the field. Because the recognition is not in the description. The recognition is in the hands. Elias Mast had been reading soil with his hands for 51 years, since his father first pressed his palm into a Lancaster County field in 1971 and told him to feel what was there. He was 67 years old in the spring of 2018, and he had been farming 280 acres of Lancaster County, Pennsylvania without synthetic fertilizer or pesticide since 1983, because the Amish community he belonged to did not use these things and because he had never needed them to grow what the land was capable of growing. He was not, by the convention of the precision agriculture consulting business, a sophisticated farmer. He did not have a soil monitoring system. He did not have GPS-guided equipment or variable rate application technology or yield mapping. What he had was his hands. And his hands knew things that the $15,000 precision soil mapping service had taken 3 weeks to approximate. This is the story of how he knew it, and who said he didn't, and what happened when the two of them looked at the same field and one of them was right, and then one of them was honest about it. Elias Mast drove his horse across the south field in the third week of April 2018 and stopped at the low corner where the drainage was slow and pressed his hand into the soil the way his father had pressed his hand into the soil and the way his father's father had pressed his hand into the soil, going back to the generation that had come from Switzerland and found that Lancaster County was good land and had stayed. He was 67 years old, with the hands of a man who has worked outdoors for most of his life, large and calloused and permanently darkened in the creases from the contact with soil that does not entirely wash out. He wore the plain clothes of his community, dark trousers, suspenders, the broad-brimmed hat that marked him as Amish to anyone in the county who needed that marking, which was not many people because Lancaster County had been Amish country for 300 years and the people in it had long since ceased to mark each other by anything so obvious as clothing. He pressed his hand into the south field's low corner and felt what was there. The soil was wet but not saturated. The drainage tile he had put in 12 years ago was working. The surface had the slight give of soil approaching planting moisture without having reached it. He pressed harder and felt the resistance, the specific pushback of a well-structured soil that was wet but intact, its aggregates still holding their form. He lifted his hand and looked at what clung to it. Dark. Almost black in the low corner, where the organic matter had been building for 40 years under the management his father had established, the cover crops, the composted manure, the careful tillage that broke the surface for planting without destroying the structure beneath. He moved to the high corner of the field, pressed again. Lighter color. The aggregate smeared slightly rather than crumbling clean. He thought, needs attention. The high corner had been losing organic matter since the wet year of 2011 when he had been forced to till earlier than he wanted. He noted both observations in the small notebook he carried in his shirt pocket. He drove to the next field. Abraham Mast had farmed 280 acres in Lancaster County for 43 years, and in the spring of 1971, when Elias was 20 years old and beginning to take on more of the farm's operational decisions, Abraham had walked him through every field on the property. Not to show him where things were. Elias had grown up on this land and knew every field, every fence line, every drainage tile outlet. Abraham walked to show him how to read. They spent a full week on the soil, pressing, breaking, smelling, watching how water moved after rain, Abraham had a vocabulary for what he found that was not the vocabulary of the soil science textbooks at Penn State but the vocabulary of 3 generations of Lancaster County Amish farming, words in Pennsylvania Dutch for the soil conditions that mattered, words that described not just what the soil was but what it needed and what it was capable of. Gut erd, Abraham said, pressing his hand into the best section of the South Field Center, the section that had been in the family's most careful management since the 1890s. Good earth. When you feel this, you know the land is working the way it should work. Everything below the surface is alive and moving. The water goes through, the roots go down, the nutrients move. You can feel it. Elias pressed his hand into the same section. He felt the give, the specific resistance, the way the soil released from his palm when he lifted. What am I feeling? He said. Structure, Abraham said. Pore space. The channels between the aggregates where the water and the air and the roots travel. When the structure is good, the soil is alive. When the structure is gone, compacted, or depleted of organic matter, or damaged by tillage at the wrong time, you feel the difference. How long until I can feel the difference reliably? Elias said. Abraham thought for a moment. 5 years to begin, he said. 20 years to trust. 50 years to know. He was 70 years old when he said this, and he had been pressing his hands into Lancaster County soil for 50 years. Elias was 20 and he thought, 50 years is a long time. He thought this without discouragement, because 50 years was simply the number, and the number was what it was, and he had better start. He started that spring. The Precision Soil Mapping Service was called TerraSense Agricultural Analytics. It had been founded 4 years earlier by a man named Jonathan Webb who had a PhD in soil science from Penn State and who had recognized that the gap between what soil science knew and what most farmers were applying to their fields was large enough to build a business in. TerraSense offered comprehensive soil mapping, grid sampling at 2.5-acre resolution, laboratory analysis of 14 soil parameters, and color-coded management zone maps with variable rate application recommendations. For a 280-acre farm like Elias Mast's, the initial mapping cost $4.200, with annual updates at $2.240. Over 5 years, approximately $13.400. The TerraSense regional sales representative for Lancaster County was Marcus Cole, 34 years old, with a master's degree in precision agriculture from Delaware Valley University. He was competent and genuinely knowledgeable about the systems he sold, and his pitch was not dishonest. The service did what it described. He had been trying to sell the service to Elias Mast for 2 years, without success. The first visit, in 2016, Elias had listened carefully, asked technical questions, and said he would think about it. The second visit, in 2017, had ended the same way. Marcus had described Elias afterward, in a call to Jonathan Webb, as the kind of customer who isn't resistant because he doesn't understand the technology but because he understands it better than he's supposed to. What questions does he ask? Jonathan said. Marcus told him. Jonathan Webb drove from Philadelphia to Lancaster County the following week. Jonathan Webb had grown up in suburban Philadelphia and had spent 7 years in graduate school and postdoctoral research before founding TerraSense. He was 41 years old in the spring of 2018, lean and energetic, with the specific confidence of someone who has built something that works. Before he drove to Lancaster County, he read Elias Mast's soil test results, the standard Penn State soil test that Elias submitted every 3 years through the County Conservation District. The results were extraordinary. Organic matter ranging from 4.8 to 7.2% across the farm's fields. pH uniformly between 6.2 and 6.8 without lime application in the past 15 years. Phosphorus and potassium in the high sufficiency range despite no synthetic fertilizer inputs since 1983. Cation exchange capacity averaging 18.2 milliequivalents per 100 grams, exceptional for Lancaster County soils, which typically ranged from 12 to 16. Jonathan had seen results this good before, but only in research plots under carefully controlled experimental conditions. He had never seen them from a farm operating without synthetic inputs, without variable rate application, without any of the management tools that his company sold. He drove to Lancaster County with a specific question in his mind: how does he produce these results without the tools that are supposed to produce them? Elias was in the machine shed when Jonathan arrived, repairing equipment with the methodical patience of a man who has been repairing equipment all his life. "I've read your soil test results," Jonathan said, after they had shaken hands. "They're exceptional." "I know," Elias said. "I'd like to understand how you achieve them," Jonathan said. Elias looked at him for a long moment. He had learned to distinguish between people who were asking because they wanted to sell him something and people who were asking because they genuinely wanted to know. Jonathan Webb was asking because he genuinely wanted to know. "Come walk the fields with me," Elias said. They spent 3 hours walking Elias Mast's fields on a Thursday afternoon in April. Elias walked the way he always walked fields, stopping frequently, crouching, pressing his hands into the soil at different points, breaking clods to look at the structure inside, pulling plants to examine the roots. He was not performing for Jonathan Webb, he was doing what he always did, at the pace he always did it. At the south field's low corner, Elias stopped and pressed his hand into the soil. "This is the best section of this field," he said. 40 years of building. Feel the structure, the aggregates, the pore space. When you press, there's resistance from the structure, not from compaction. Jonathan pressed his own hand into the soil. He felt the resistance, the specific texture of well-aggregated soil. "How do you distinguish structure resistance from compaction resistance?" Jonathan said. "Structure resistance releases when you lift," Elias said. "Compaction resistance follows you up, it doesn't release, it clings." He demonstrated, pressing down, feeling the resistance, lifting slowly and showing how the soil fell cleanly from his palm. Healthy soil lets go. Compacted soil holds on. Jonathan filed this distinction carefully. He had not encountered it articulated this way in the literature, though he recognized it immediately as accurate. At the high corner of the south field, Elias stopped again. "This is where I need to work," he said. 3 years of attention before it comes back to where it should be. The soil test data shows slightly lower organic matter in the northwest quadrant, Jonathan said. He had the test results on his phone. 4.9% versus 6.8% in the southeast quadrant. "The northwest high corner," Elias said. He pointed to it. "You knew without looking at the test results," Jonathan said. "I knew without the test results," Elias said. "The color is lighter. The texture is different, the soil tends to smear rather than crumble when wet. The roots on the cover crop were shorter in that section last fall. The earthworms are fewer when I dig there." "You integrate multiple indicators," Jonathan said. "I read what's there," Elias said. "The test confirms what I already know. Sometimes it tells me something I've missed. Not often, but sometimes." "What are the specific indicators you're integrating?" Jonathan said. "Color," Elias said. "Texture. Structure, how the aggregates hold and release. Smell. Root development in the cover crop. Earthworm presence. Water infiltration after rain. The color and growth pattern of the cash crop through the season. All of these, together, over time." "Can you quantify any of them?" Jonathan said. "The earthworms I count sometimes," Elias said. "The color I compare to reference samples. The others, I compare them to memory. To what I have seen in this same field in other years. The reference is in here." He touched his temple. "And in here." He held up his hands. Jonathan was quiet. He was thinking about why the indicators were all pointing in the same direction, and recognizing, with the clarity of someone encountering an insight he should have had earlier, that they were correlated because they all reflected the same underlying condition. The organic matter was either there or it wasn't. All the indicators showed the same thing because they all reflected the presence or absence of organic matter and biological activity. A skilled observer integrating multiple correlated indicators was doing something more robust than he had initially assumed. Marcus Cole had been preparing his presentation on TerraSense for the Lancaster County Agricultural Extension's Spring Farmer Meeting for 3 weeks. He arrived at the meeting hall in Lidditz on the second Thursday of April with 47 slides and the confidence of a man who had given a version of this presentation many times. 63 farmers filled the hall. The county extension agent sat in the front row. Jonathan Webb sat in the back. Elias Mast sat in the third row. Marcus's presentation covered the science of spatial soil variability, the real and documented variation in soil properties across a field that grid sampling was designed to capture. He showed maps with organic matter ranging from 2% to 6% within the same 40-acre field. He showed yield implications of uncorrected fertility imbalances. He showed cost savings from variable rate application. The presentation was accurate. The science was real. During the question period, Elias raised his hand. "Mr. Cole," he said. "When you take a grid sample at 2.5-acre resolution, how much of the spatial variability in a field does the grid capture?" "Research has shown that 2.5-acre grids capture 85 to 90% of the economically significant variability," Marcus said. "And the remaining 10 to 15%? Below the economically significant threshold, Marcus said. In a field with organic matter ranging from 4.9 to 6.8%, is the variation between those zones economically significant? Elias said. Marcus knew the answer. At current corn prices, approximately 12 to 18 bushels per acre in yield difference. It can be, he said carefully. My south field's high northwest corner has lower organic matter than the rest of the field, Elias said. That corner is approximately half an acre. Your 2.5-acre grid would merge it with the surrounding soil and average the reading. The recommendation for the merged zone would be based on the average, not on the specific condition of the corner. The room was quiet. Marcus knew Elias was correct. TerraSense uses adaptive sampling in areas of high within-zone variability, Marcus said. If the initial map shows high variability in a zone, we recommend increased sampling density. How does the initial assessment identify within-zone variability before you've sampled at higher density? Elias said. The initial grid sampling provides the baseline variability assessment, Marcus said. Which may not capture the variability that indicates the need for higher density sampling, Elias said. Marcus looked at the back of the room. Jonathan Webb's expression told him nothing, which was more informative than an expression would have been. Mr. Mast, Marcus said, what method do you use to identify that half-acre corner as a distinct management zone? I walk the field, Elias said. I press my hands into the soil. I read the indicators. And your reading has been validated by the Penn State soil test results, Marcus said. It was not sarcasm. It was an acknowledgement. The test confirms what the reading shows, Elias said. The reading shows what the test would confirm. The reading is faster, Marcus said. The reading is free, Elias said. Jonathan Webb drove back to Philadelphia that evening and sat in his office until midnight, not doing calculations but thinking. He had built TerraSense on the premise that spatial soil variability was real, significant, and not captured by standard management practices. This premise was correct. The science was solid. The business was working. What Elias Mast had demonstrated was not a challenge to the premise. He had said something more specific, that his hands could identify the zones of variability that the 2.5-acre grid was designed to identify, faster and without cost, because his integration of multiple real-time indicators captured information that a point-in-time grid sample could not. But the indicators he described, color, texture, structure, smell, root development, earthworm presence, were all correlated. They reflected the same underlying condition. That was what Jonathan had understood in the field walk, and it was what made Elias's reading more robust than a single indicator assessment. He wasn't guessing from one clue. He was triangulating from a dozen clues that all pointed to the same truth. Jonathan thought carefully about what Elias's reading could not do. Two things. The first was subsurface variability, the variation in soil properties below the surface layer that hands-on reading could not directly access. Elias's reading was excellent for the top 6 to 8 inches. Below that, direct observation was impossible. The laboratory analysis of probe cores provided information about subsoil conditions that surface observation couldn't reach. The second was the spatially explicit archive. Elias's notebooks provided historical context, but they were not a map. They could not show, year over year, exactly where the organic matter boundary in the northwest corner was and how it had moved. A spatial archive could show that, and could show it to someone who hadn't been there for the previous 50 years. Jonathan wrote these two things in his notebook. Then he wrote a third thing. What would happen if Elias Mast's reading and TerraSense's grid sampling were used together? He did not write the answer immediately. He thought about it for another hour. The answer, when he wrote it, was simpler than he expected. The methods were not competitive. They measured different things. A farmer with Elias's calibration needed TerraSense for the two things his reading couldn't do. A farmer without Elias's calibration needed TerraSense for the primary spatial variability assessment itself. The mistake TerraSense had been making, the mistake that Marcus's pitch embodied, was treating the service as a substitute for field knowledge. It was not. It was a complement to field knowledge, more valuable when the field knowledge was limited and less valuable when the field knowledge was deep. He called Marcus. Set up another meeting with Elias Mast, he said. Not a sales meeting. A conversation about what the service can and can't do for a farmer of his calibration. Ruth Mast had been married to Elias for 43 years and had managed the farm's financial records since the beginning of their marriage, because she was better with numbers than Elias and because Elias understood this and had never pretended otherwise. She kept the records in a system that combined the paper ledger standard in their community with a modified version of the double-entry bookkeeping she had learned from her father, who had been a miller and who had understood numbers with the precision that milling required. The financial records of the Mast farm were, in their way, as detailed as Elias's soil notebooks. Income and expenses for each growing season. Yields from each field. Input costs, labor costs, equipment costs. The trajectory of the farm's economics over 43 years. The trajectory was good. Steady and sustainable, the kind of good that had allowed them to pay off the farm mortgage in 2001 and to help their 3 children establish their own farms. Modest by the standards of the world outside their community and comfortable by the standards of the world inside it. Ruth heard about the extension meeting, from the wife of a neighbor who had also attended. She heard that Elias had asked questions the TerraSense salesman could not fully answer, and that Jonathan Webb, the company's founder, had been watching from the back row. She asked Elias about it that evening. The presentation was accurate, Elias said. The service does what it says it does. But you asked questions, Ruth said. I asked what it can't do, Elias said. Which is different from asking what it can do. What can it do? Ruth said. It can't read the half-acre corner of the south field as a distinct management zone, Elias said. It averages it into the surrounding zone. Which you read by hand, Ruth said. Which I read by hand, Elias said. How much does the mismanagement of that corner cost? Ruth said. She was already thinking like an accountant. 12 to 15 bushels per acre per year, if the corner receives management appropriate to the average zone rather than to its specific condition, Elias said. The corner is about half an acre. 6 to 8 bushels per year. At current prices, $12 to $15 per year, which over 40 years accumulates to about $500, Ruth said. Yes, Elias said. Which is why I haven't purchased the service. The initial mapping costs $4,000, Ruth said. Yes. Ruth looked at the financial records on the desk between them. Jonathan Webb is coming back, she said. It was not a question. Marcus will call, Elias said. Yes. When he comes, Ruth said, show him the financial records alongside the soil notebooks. Not just the soil data. The financial outcomes that the soil reading has produced. Elias looked at her. Why? Because he's trying to understand what the reading is worth, Ruth said. He should see both what the land is and what the reading of the land has meant. Jonathan Webb drove to Lancaster County on the first Tuesday of May with a soil probe, a set of reference samples, and a Munsell color chart, the standard tools of field soil assessment that he had not carried on a farm visit since his graduate school days. He had decided on the drive from Philadelphia that the meeting needed to happen in the field rather than at a table. Elias was waiting in the lane. He looked at Jonathan's equipment. You brought field tools, Elias said. I want to understand what you read, Jonathan said. Not what you describe. What you actually read. They walked to the south field. Show me how you assess this field, Jonathan said. I'll take probe samples at the same locations and we'll compare what the lab shows to what your reading shows. Elias pressed his hand into the soil at the first location, the southeast center. Good structure. Aggregates hold well. Color is dark, close to tenure 2-1. Smell is strong. Organic matter above 6%, probably close to 7. Jonathan drove the probe into the same location, pulled the core, held it against the Munsell chart. Tenure 2 halves, he noted. He bagged the sample. They moved to the northwest high corner. Different, Elias said, pressing in. The aggregates smear when wet rather than crumbling cleanly. Color is lighter. Smell is weaker. Organic matter below 5%, possibly closer to 4.5. Jonathan drove the probe. Tenure 3 halves. He bagged the sample. They continued across the field, 11 locations in 40 minutes. At each one, Elias gave his reading before the probe went in. When they were done, Jonathan sent the samples to the laboratory by overnight courier and entered Elias's estimates into his laptop. They walked back to the farmhouse and Ruth made coffee and Elias brought the financial ledgers from the study shelf and set them beside the soil notebooks on the kitchen table. Jonathan looked at the 2 sets of records side by side. The soil notebooks and the financial records, he said. The same story told in 2 languages, Ruth said. The notebooks show what the land is. The ledgers show what the reading of the land has produced. Jonathan looked through both. The correlation was visible even without detailed analysis. The years when the soil notebooks showed management interventions corresponded to the years when the financial records showed better than expected yields on the affected fields. The lab results will come in 48 hours, Jonathan said. Then I want to come back and compare them to the reading. You already know what you'll find, Elias said. I know what the Moonsel color readings suggest, Jonathan said. I want to see how accurate the full integration is, the color plus the texture plus the smell plus the structure assessment. Come back Thursday, Elias said. The laboratory results came back on Thursday afternoon. Jonathan read them against Elias's estimates. The southeast center, Elias had said above 6%, probably close to 7. The lab returned 6. 8. The northwest corner, Elias had said below 5, possibly closer to 4.5. The lab returned 4. 9. The remaining 9 locations ran the same way, Elias's estimates within 0.5% of the laboratory analysis at every single point. Jonathan drove to the farm that evening and set his laptop on the kitchen table and showed Elias and Ruth the comparison. He read through it location by location, the southeast center at 6. 8 against Elias's above 6, the northwest corner at 4. 9 against his below 5. 11 locations, 11 matches, none off by more than 0.5%. Your estimates match the lab results at every location, Jonathan said. I know, Elias said. Within 0.5% at the widest, Jonathan said. I've been calibrating for 51 years, Elias said. The calibration you've built, Jonathan said carefully, is more accurate at your specific farm, in your specific soil type, than the calibration I use for the county as a whole. Yes, Elias said. Because your calibration is specific to one place, Jonathan said. And mine has to work across many places. Yes, Elias said. Jonathan was quiet for a moment. The TerraSense service, he said, is designed for farmers who don't have your calibration. Farmers who farm multiple soil types, or who have recently purchased land they don't know well, or who want to track changes in a format that can be shared with an agronomist or a lender. I know, Elias said. For those farmers, the grid sampling fills a gap that your reading fills for you, Jonathan said. For those farmers, yes, Elias said. For you, Jonathan said, the grid sampling would confirm what you already know, at a cost of $15 per acre for the initial mapping. Which I have already paid, Elias said, through 51 years of attention. Jonathan heard something in this that he wanted to understand better. The attention has a cost, he said. 51 years of field reading, maintained at this level of calibration, what does that cost? Time, Elias said. An hour a week through the growing season, less in winter. More in spring and fall. Jonathan calculated silently. 51 years. 40 growing weeks per year. An hour a week. 2,040 hours. At a standard agricultural labor rate, he began, that's. Don't do that calculation, Elias said. His voice was not sharp but it was clear, a line had been approached. Jonathan stopped. The time is not a cost in that sense, Elias said. The reading is not separate from the farming. The reading is the farming. I don't read the soil and then farm. Reading the soil is how I farm. Jonathan set down his pen. He thought about this for a long time before speaking. The reading is not an input to the farming process, he said slowly. It is the farming process. Yes, Elias said. Which means the question I was asking, what does the reading cost, is the wrong question, Jonathan said. The reading doesn't cost anything separate from farming. It is farming, at this level. Yes, Elias said. Then the question is, what does TerraSense offer a farmer for whom the reading and the farming are the same thing? Elias looked at him. Now you're asking the right question, he said. Jonathan Webb proposed a demonstration, and Elias agreed to it, because the demonstration was honest, designed to show what each method could and could not do. TerraSense would do a complete precision soil mapping of Elias Mast's south field, at no charge, at 1 acre resolution rather than the standard 2.5 acre resolution. Elias would do his reading of the same field at the same time. Both readings would go to an independent party, the Lancaster County Conservation District, for comparison. The independent reviewer was Dr. Patricia Yoder, a soil scientist who had been at the Conservation District for 22 years and who knew Lancaster County soils as well as anyone in the state outside of Penn State's Soil Science Department. Dr. Yoder spent a full day walking the south field with the TerraSense map in one hand and Elias's reading in the other. What she found. On the primary management zones, areas with distinct fertility characteristics large enough for the 1 acre grid to capture, the TerraSense map and Elias's reading were in agreement. The southeast center was high organic matter in both. The northwest corner was low organic matter in both. On the half-acre northwest boundary zone that Elias had identified at the extension meeting, the TerraSense map, even at 1 acre resolution, had merged it with the adjacent zone and assigned it the average's characteristics. Elias's reading had identified it as distinct. On two locations where Elias's reading indicated recent management interventions, a section where cover crop had winter killed and a section where a tile outlet had been partially blocked, creating temporary anaerobic conditions, the TerraSense map did not capture these because they were not reflected in the laboratory analysis of soil chemistry. Elias's reading had flagged both. On the subsurface, the soil chemistry below 8 inches, the TerraSense map provided specific data that Elias's reading could not. In two locations, the laboratory analysis showed subsoil phosphorus levels that would affect management decisions that Elias's surface reading could not have indicated. Dr. Yoder's report was precise and careful. Both methods capture the primary spatial variability of the field's soil properties. The precision soil mapping provides specific quantitative data, including subsurface data, in a spatially explicit format that can be archived and compared across years. The farmer's field reading provides real-time integration of multiple surface and near-surface indicators, with higher spatial resolution in some cases, at no monetary cost but with significant time investment and a calibration requirement of several decades. The methods are complementary rather than competitive. The precision soil mapping identifies conditions the field reading cannot access, subsurface chemistry and spatially explicit quantitative records. The field reading identifies conditions the mapping cannot capture, real-time surface dynamics, subgrid resolution zones, and management-induced temporary conditions. Recommendation: farms with farmers of Mr. Mast's calibration level and field tenure would benefit from precision soil mapping primarily for subsurface data and long-term archival purposes. Farms with farmers of shorter tenure or multiple soil types would benefit more substantially from the mapping service's primary spatial variability assessment. Jonathan read the report 3 times. Ruth Mast sat at the kitchen table in May 2018 and did the accounting she always did when a significant question arose about the farm. She could trace, through the financial records, the specific decisions that Elias's field reading had enabled and estimate what those decisions had contributed to the farm's outcomes. In 1994, Elias's reading of the East Field had identified early symptoms of soil compaction, texture changes that preceded visible crop stress by 2 seasons. He had responded with a cover crop program and reduced fall tillage. A farmer without Elias's reading ability would likely have detected the compaction only after visible crop stress appeared, 2 seasons of suboptimal yield on 45 acres. Ruth estimated the value of the early detection at approximately $4.200 in avoided yield loss. In 2003, Elias's reading of the North Field had identified a section with anomalously low biological activity. The smell was wrong, the earthworm count was low, the structure was degrading. Investigation found a cracked drainage tile creating temporary anaerobic conditions. Repair restored the section. Without the reading, the failure would have been detected only after several seasons of poor yield. Ruth estimated the value at approximately $7.800. In 2011, the wet year, Elias's reading had identified which fields were approaching tillage tolerance before they reached it. His careful management of tillage timing that year had prevented compaction on 3 fields that other farmers in the township had compacted in the difficult conditions. The recovery from soil compaction typically required 3 to 5 years. Ruth estimated the value at approximately $22,000 in avoided compaction recovery costs and yield loss. She totaled the specific cases she could trace through the 1983 to 2018 records, approximately $34,500 in documented value from field reading decisions, excluding the routine management decisions that the reading informed continuously every season. The TerraSense service, over the same 35 years at current pricing, would have cost approximately $200,000. She also calculated what Elias's reading was worth compared to standard management without either, the management that most Lancaster County farmers without precision mapping or deep field reading applied. She estimated this conservatively at approximately $80,000 in aggregate yield improvement over the same 35 years. She showed the calculations to Elias. The reading is worth $80,000 over 35 years, he said. At minimum, Ruth said. The cases I could document specifically. The routine decisions that the reading informs every season are harder to quantify, those add to the total, not subtract from it. And the reading cost 2,000 hours, Elias said. The labor produced the calibration, Ruth said. The calibration produced the value. The first 1,000 hours produced less than the last 1,000 hours. The calibration compounds. My father's calibration is in my calibration, Elias said. Yes, Ruth said. Which means the 2,000 hours is not the full picture. The calibration that produces the value includes whatever portion of your father's calibration survived the transmission. He walked me through every field for a week in 1971, Elias said. He answered my questions for 20 years after that. 4 generations of calibration, then, Ruth said. Your grandfather's generation established the management practices. Your father built the reading on those. You built on his. Isaac is building on yours. Minimum 4 generations, Elias said. Possibly 5. Ruth looked at the 2 records side by side, the soil notebooks and the financial ledger. Jonathan Webb should see both of these together, she said. Not just the lab results against your estimates. The trajectory. What the reading has built, in this land and in these numbers, over time. Jonathan Webb spent the month of June 2018 revising something he had believed for 7 years. He had founded TerraSense on the premise that precision soil mapping was the primary solution to the spatial variability problem in agriculture. For most farmers, in most situations, this was still true. What Elias Mast had shown him was that the solution to the spatial variability problem was not uniquely the grid sampling and laboratory analysis approach. It was the ability to read spatial variability in the field, accurately, in real time. The grid sampling built this ability into a service any farmer could purchase. The hands-on reading built it into the farmer through decades of attention. Both were real. Neither was complete. He had also understood, sitting at Elias's kitchen table with the soil notebooks and the financial ledger side by side, something Ruth had said, the same story told in 2 languages. The soil quality that the notebooks documented and the financial outcomes that the ledger recorded were not separate accounts, they were the same account in different notation systems. The reading connected them. He thought about what TerraSense's service missed by treating soil mapping as an isolated technical service rather than as part of a farm's integrated knowledge system. The mapping produced data. The data needed to be integrated with everything else the farmer knew about the land. For farmers who had Elias's depth of integrated knowledge, adding the mapping data was relatively easy, they already had the framework to use it. For farmers who didn't, the mapping data arrived without the framework and often sat underused in a software system. He had been selling data to farmers who needed knowledge. He called Marcus. I want to change our sales pitch, he said. Not the product, the honest description of what the product is and who benefits most from it. Marcus listened. We've been presenting the service as a replacement for whatever the farmer is currently doing, Jonathan said. We should be presenting it as what it actually is, a service that provides soil variability information that would otherwise require decades of field reading to develop. For farmers who have those decades of field reading, the primary value is in the subsurface data and the archive. For farmers who don't, the primary value is in the variability assessment itself. That changes the pitch significantly, Marcus said. It makes the pitch more honest, Jonathan said. And it respects what farmers like Elias Mast have actually built. We've been implicitly suggesting that what they have is insufficient. What they have, in many cases, is more accurate than what we can provide. What they're missing is the subsurface and the archive. We should sell them what they're missing, not what they already have. Would Elias Mast buy the service under the revised pitch? Marcus said. He might buy the subsurface sampling component, Jonathan said. At a reduced price reflecting the limited additional value it provides over his existing reading. So we're selling a smaller product to a better farmer, Marcus said. We're selling an honest product to a farmer who requires honesty, Jonathan said, and we're learning something from that farmer that will make us better at selling to every farmer. The Lancaster County Agricultural Extension held its fall farmer meeting in October 2018, and Jonathan Webb had asked to present. Not a TerraSense sales presentation. Something different. He titled it, What Precision Soil Mapping Can and Cannot Do. He described the TerraSense service accurately, what it measured, what it didn't, where it provided substantial value and where it provided limited marginal value. He described the specific cases where the service was most valuable: farms with multiple soil types, recently purchased land, farmers without extensive field tenure on the specific land they were farming. He described the specific cases where the service provided limited additional value: farms where the farmer had extensive field tenure and had developed field reading calibration over many years. For these farmers, the primary value was in the subsurface data and the spatially explicit archive. Then he showed the comparison from the South Field demonstration. He did not name Elias. He described him as a Lancaster County farmer with 51 years of field reading on the same land. He showed the estimates against the laboratory results, the southeast center at 6.8 against an estimate of above 6, close to 7, the northwest corner at 4.9 against an estimate of below 5, possibly 4.5, 11 locations, 11 matches, none off by more than 0.5%. This farmer reads his soil with his hands, Jonathan said. His estimates match the laboratory analysis at every location across his south field. He does not need TerraSense's spatial variability assessment. He can see it. The room was quiet. What he cannot see, Jonathan continued, is the subsurface chemistry below 8 inches. And he cannot produce a spatially explicit archive that shows how his field's conditions are changing over time in a format that could be shared with an agronomist or a lender or the next person who farms that land. He paused. For those two things, the service has value even for a farmer of his calibration. He looked at the room. I've been selling this service for 4 years, telling farmers it gives them better information about their soil than they currently have. For most farmers, that's true. For some farmers, the ones who have been reading their specific fields for a long time, the way their parents and grandparents read them, it's not entirely true. The service gives those farmers different information. Some of it is better, some of it is redundant. Knowing the difference matters. To the farmer and to me. Marcus Cole was in the 5th row. He had drafted an earlier version of this presentation and Jonathan had revised it substantially. Watching the room, he understood why the revision was necessary. The farmers were listening differently than they listened to the sales presentation. They were listening the way you listen to something true. Elias Mast was in the 3rd row. He raised his hand after the presentation. Mr. Webb, he said. You said that for some farmers, the service gives different information rather than better information. The subsurface data and the archive. Yes, Jonathan said. If I use the subsurface sampling component of your service every 3 years, Elias said, combined with my field reading for the spatial variability assessment, what would that cost? Marcus did rapid arithmetic. For subsurface only sampling at your farm's acreage, every 3 years, Jonathan said, approximately $600 per sampling event. $200 per year on average. For subsurface data and a spatially explicit record of subsurface conditions over time, Elias said. Yes, Jonathan said. That I will consider, Elias said. Elias Mast had 2 sons and 1 daughter. The one who was farming was Isaac, 38 years old in 2018, who had been farming his own land in the adjacent township since 2008. Isaac had grown up on his father's farm and had spent 20 years learning the way all Amish children learn farming, through presence and participation and the slow accumulation of experience. By the time he started farming his own land, he had approximately 25 years of accumulated field contact. But not on his own land. His land was 2 townships away, on soil structurally similar but not identical, Lancaster County silt loam, the same series, but with different management history and different drainage characteristics. The calibration that Isaac had built on his father's farm was a starting point, not a complete reading. Isaac knew this. He had told Elias when he bought his farm, I know your ground. I don't know this ground yet. It will take years. It will take years, Elias had agreed. Start now. Isaac had started. He pressed his hands into his own fields from the first spring, comparing what he found to what his father's land had taught him to look for, noting the differences. He kept notebooks. He submitted the annual Penn State soil test. In May 2018, after the fall extension meeting and the conversation with Jonathan Webb, Elias drove to Isaac's farm and walked the fields with him. They spent a full day on it, the same kind of day, the same kind of walk, that Abraham Mast had done with Elias in 1971. At the end of the day, at Isaac's kitchen table, Elias said, You're reading the surface layer correctly. The color assessments match what the test shows. The texture assessment is also good. But? Isaac said. The structure assessment is not yet reliable, Elias said. You're reading compaction correctly, you can feel the clinging resistance when you lift. But you're not yet reliably distinguishing between structure that is degrading and structure that is recovering. They feel similar in the short term. How many more seasons? Isaac said. 5 to 8, Elias said. Before that distinction is reliable. Isaac nodded. This was the time frame he had expected. In the meantime, Elias said, Jonathan Webb's subsurface sampling would give you the quantitative baseline your reading can't provide yet. Not to replace the reading, to support it while the calibration builds. Isaac looked at him. You're recommending the TerraSense service. I'm recommending the subsurface component, Elias said. For your situation, at your calibration level, on land you've been reading for 10 years. A different recommendation than I would make for myself. And in 10 more years? Isaac said. In 10 more years, Elias said, you'll know whether you still need it. 5 years to begin, Isaac said quietly. 20 years to trust. 50 years to know, Elias said. You're in the first 10. Use the tools that support the reading you're building. Don't mistake them for the reading itself. Jonathan Webb drove to Lancaster County in October 2018, after the fall extension meeting, and walked the south field with Elias Mast one more time. The field had been harvested, the cover crop was establishing, the soil and the specific condition of a field that had completed its annual cycle and was beginning the next. I want to understand one more thing, Jonathan said. Ask, Elias said. The knowledge you have of this field, the reading you've built over 51 years. When you're no longer farming, how much of it transfers? Elias pressed his hand into the soil at the southeast center and held it there for a moment before answering. 50%, he said. Maybe 60. My son Isaac grew up here. He pressed his hands into this soil from the time he was 5 years old. What he absorbed without knowing he was absorbing it is more than I could teach him explicitly. And the other 40%? Some of it is in my notebooks. The observations going back to 1983. He can read them, and they will tell him things about this field that his own memory doesn't hold. And the rest? Jonathan said. The rest is in me, Elias said. And it will go with me. He said this without drama, as a fact, as something he had thought about and accepted. My father said the same thing. He told me that what he had built in his hands could not be fully transferred to mine. That I would have to build my own, from the foundation he provided. Does that bother you? Jonathan said. Elias looked at the field, the establishing cover crop, the dark soil, the land that had been in his family's care for 4 generations. It is the nature of this kind of knowledge, he said. It lives in one person and it transfers imperfectly. That is not a failure. That is what it is. The TerraSense archive, Jonathan said, is an attempt to capture some of what would otherwise transfer incompletely. Not the reading itself, the record of what the reading has found, so that the next person can see the trajectory of the field without having been here for all of it. Yes, Elias said. That is useful. For Isaac on my farm, the archive would tell him what the field has been. My reading tells me what the field is. Both are useful. Neither is complete without the other. The report shows what the hands can't reach, Jonathan said. And the hands show what the report can't capture, Elias said. Yes. Jonathan looked at the field for a long time. When I started TerraSense, he said, I thought the problem I was solving was that farmers didn't know their soil well enough. I thought the mapping gave them knowledge they didn't have. Some farmers, Elias said. Some farmers, Jonathan said. And for other farmers, the problem is not that they don't know their soil. The problem is that what they know is in them and not on paper, and when they leave the farm, the knowledge is at risk of leaving with them. The archive doesn't solve that problem fully, Elias said. But it catches some of it. Some is better than none, Elias said. They walked back to the lane in the October afternoon, through the smell of fall soil and establishing cover crop, and neither of them said anything more because they had said what needed to be said. Elias Mast walked his granddaughter through the south field in the spring of 2021, when she was 14 years old. Her name was Hannah, and she was Isaac's daughter, and she had grown up on Isaac's farm but had spent enough time at her grandfather's farm, summers, harvest seasons, planting weeks, that the land was familiar without being fully known. Elias pressed his hand into the soil at the southeast center and said, "What do you feel?" Hannah pressed her own hand. She was 14 and she had been doing this since she was old enough to be in the field and she knew what she felt. "It's warm," she said. "And soft. And when I press, it pushes back." "The pushback is the structure," Elias said. "Feel the difference between this," he pressed firmly and lifted, "and this." He moved to the northwest corner and pressed and lifted. Hannah followed. "The corner is different," she said. "It's stickier." "That's close to right," Elias said. "The corner soil tends to smear rather than crumble. The aggregates are less stable." "Why?" Hannah said. "Less organic matter," Elias said. "When the organic matter is high, the aggregates are cemented by fungal hyphae and bacterial products. They hold their form and crumble cleanly. When the organic matter is lower, the aggregates are less stable. They smear." "How much less organic matter?" Hannah said. "About 2%, Elias said. The center is close to 7%. The corner is close to 5. "Can you tell that from feeling it?" Hannah said. "Not the numbers," Elias said. "I can tell the direction, higher or lower. The numbers come from the laboratory." "But you knew before the laboratory," Hannah said. "I knew the direction," Elias said. "The laboratory tells me by how much." They walked the field for an hour, stopping at each of the 11 locations Elias had been reading for 51 years. At each stop he pressed his hand and described what he felt, and then let Hannah press her hand and asked her what she felt. Her descriptions were not accurate in the way his were accurate. She was beginning. She was learning the vocabulary before she could learn to read. Your great-great-grandfather established this farm's management in the 1890s, Elias told her as they walked back to the lane. Your great-grandfather learned to read this soil from him. I learned to read it from your great-grandfather. Your father is learning to read his own farm, different soil, different history, but the same methodology. And you're teaching me, Hannah said. I'm showing you where to start, Elias said. The teaching takes longer than one afternoon. How long? Hannah said. Your great-grandfather told me, 5 years to begin, 20 years to trust, 50 years to know. He looked at her. You have started. Now you continue. Hannah looked at the south field, the dark soil, the establishing cover crop, the land that her family had been reading for 4 generations. What if I farm somewhere else? She said. Not this farm. Then you start again, Elias said. What you learn here is the methodology. What you learn about this specific land, the specific calibration, does not transfer to a different land. You bring the way of reading. You build the reading of the new place from the beginning. So anywhere I farm, Hannah said, I can start. Anywhere you farm, Elias said, you can start. The beginning is always the same. Press your hands into the soil and feel what is there. Write down what you feel. Come back in a week and press your hands again. The reading builds from the repetition. Hannah pressed her hand one more time into the southeast center, the best soil on the farm, 6.9% organic matter in the most recent test, the section that her great-grandfather had been building since the 1970s. I feel the structure, she said. Yes, Elias said. And the warmth, she said. It's slightly warmer than the air. The warmth is the biology, Elias said. The microorganisms. A biologically active soil runs slightly warmer than less active soil. The difference is small, perhaps half a degree, but it is there if you are paying attention. Hannah pressed her hand deeper. I think I feel it, she said. You might, Elias said. Or you might be learning to look for it. At the beginning, both are the same thing. Ruth Mast added a section to the farm's financial records in November 2021, a section she had been thinking about for 3 years, since the spring of 2018 in the conversations with Jonathan Webb and the calculations she had made about the value of the field reading. She had gone back through the financial records more carefully in those 3 years, looking for cases she had missed the first time through. She found more than she expected, smaller events, single-season management decisions that had saved losses that were hard to quantify individually but that accumulated meaningfully in aggregate. The section was titled, in her careful handwriting, What the Reading Has Built. It was not a financial calculation exactly. It was a record of the decisions that Elias's field reading had enabled, organized by field and by year, with the outcome of each decision and an estimate of its financial consequence. The 1994 compaction detection on the east field, $4, 200. The 2003 tile failure on the north field, $7, 800. The 2011 tillage timing on 3 fields, $22, 000. The accumulated management of the half-acre northwest corner of the south field, $500. And 21 other cases she had identified going back through the 1983 to 2021 records, smaller individually, significant in aggregate. Total documented value over the 38 years since Elias took over the farm in 1983, approximately $87, 000. Estimated undocumented value, the routine management decisions that the reading informed continuously, which she could trace directionally but not to specific financial outcomes, additional $40, 000 to $60, 000. Total estimated value of the field reading over 38 years, approximately $130, 000 to $150, 000. At the bottom of the section, she wrote. The reading was built by Abraham Mast and carried forward by Elias Mast. Parts of it are being built by Isaac Mast on different land. Parts of it are beginning to be built by Hannah Mast on this land. The financial records show what the reading produced in dollar terms. The dollar terms do not show what the reading is. The reading is the relationship between the farmer and the land. It is specific, and it is slow to build, and it transfers imperfectly, and it is worth more than the sum of the decisions it enabled. The reading is what makes this farm rather than any farm. She closed the ledger and placed it on the shelf beside Elias's soil notebooks, the 2 records, the financial and the ecological, side by side where they had always been. Elias Mast walked the south field in April 2024, which was the 54th spring he had walked it. He was 73 years old. His hips were slower than they had been and his knees reminded him of their existence on cold mornings, but his hands were the same hands they had always been, large and calloused and permanently darkened in the creases, the hands that had pressed into this soil more times than he had counted. Hannah walked with him. She was 17 now, and she had been walking the south field with him for 3 springs and had been pressing her hands into the soil for 3 springs and had been writing in her own notebook for 3 springs. She stopped at the southeast center without Elias stopping first. She pressed her hand into the soil. "The structure is good here," she said. "The aggregates hold cleanly. The color is dark, close to the tenure 2-1 in the chart. The smell is strong." "What does the smell tell you?" Elias said. "Biological activity," Hannah said. "Geosmin from the streptomyces. High organic matter." "Your estimate?" Elias said. "Above 6%, she said. Maybe 6. 5. The laboratory analysis from the previous fall had shown 6. 9%. Close. Close enough, for 3 springs. They moved to the northwest corner. Hannah pressed her hand. "Lighter color," she said. "The aggregates smear rather than crumble. The smell is weaker." She lifted her hand and looked at it. "Lower organic matter. Closer to 5%. 4. 8 in the last test," Elias said. "What management response?" "More compost on this section this fall," she said. "Cover crop with a legume component to add nitrogen. No tillage in the spring, direct seed into the residue." "Why no tillage?" Elias said. "Because tillage in a section with degraded structure accelerates the degradation," she said. "The aggregates are already fragile. The recovery happens from the biology up, not from the tillage." Elias looked at her. She was 17 years old and she was reading his soil and she was reading it correctly. "Your great-grandfather said the same thing in 1983, Elias said. "On this corner of this field." Hannah looked at the northwest corner. "He's the one who started the program that's been building the center up," she said. "The high organic matter section in the southeast." "Since the 1970s, Elias said. 50 years of building." "And it shows in the reading," Hannah said. "It shows in the reading," Elias said. He pressed his own hand into the northwest corner, the section that had been receiving targeted attention for 3 years now and that he had been watching for signs of improvement. He felt what he felt, the slightly stickier texture, the aggregates that smeared rather than crumbled cleanly, the smell present but not as strong as the southeast center. But different from 3 years ago. The structure was slightly better. The smell was slightly stronger. The reading was showing improvement, small, incremental, the pace at which soil biology rebuilt itself. He noted the change in his notebook. Hannah noted it in hers. The TerraSense subsurface sampling report from last fall had shown improving subsoil structure in the northwest corner, biological activity reaching deeper, pore space increasing slowly. The laboratory confirming what the reading was beginning to show. "The TerraSense report," Hannah said, "the subsurface data from last fall." "Yes?" Elias said. "It showed the northwest corner improving at 12 to 18 inches, she said. Which you can't feel from the surface. Which is why we use the report," Elias said. "The report shows what the hands can't reach," Hannah said. "The hands show what the report can't capture." "Yes," Elias said. They walked back to the lane through the establishing cover crop, through the smell of spring soil and growing things, through the land that had been in the Mast family's care since 1891 and that held, in its structure, in its color, in its smell, and its biological activity, the accumulated management decisions of 5 generations of farmers who had pressed their hands into it and read what was there. The land did not know it was being read. The farmer who read it, who had pressed her hand into the southeast center and said above 6%, maybe 6. 5 and been right to within 0.5% after 3 springs of calibration, was 17 years old and had 50 more springs ahead of her if she stayed. She would stay. Elias knew this the way he knew the soil, not from a test or a measurement but from reading what was there. The same quality of attention that she brought to the northwest corner, looking for the subtle shift in aggregate stability that indicated biological improvement, was the quality of attention that built the calibration. She was building it. The south field would teach her. Lancaster County, Pennsylvania is real, one of the most productive agricultural counties in the United States, with a long history of Amish and Mennonite farming that has maintained soil health through traditional practices in ways that continue to attract research attention. The Munsell color system referenced is real and is the standard method for describing soil color in both scientific and field contexts. The organic matter levels described, ranging from 4.8 to 7.2%, are achievable under careful management and are documented in Lancaster County soils with long histories of organic matter building. The Precision Soil Mapping Service's limitations at subgrid resolution, and the specific soil parameters described, reflect real characteristics of commercial precision soil mapping services and their acknowledged limitations in the agronomic literature. The practice of reading soil quality by hand, through color, texture, structure, smell, root development, and earthworm presence, is a real practice documented in sustainable agriculture literature and in the practices of experienced farmers across many traditions. The claim that skilled practitioners can estimate organic matter levels from field observation with reasonable accuracy has support in the agricultural and ethnopodology literature. Elias Mast, Ruth Mast, Abraham Mast, Isaac Mast, Hannah Mast, Jonathan Webb, Marcus Cole, and Patricia Yoder are fictional. Lancaster County, Pennsylvania is real. Ruth's calculation is fictional. The arithmetic it represents is not.